Welcome to The Explainer. You know, this week we're doing something a little different. We're taking all the biggest cosmic news and weaving it into one single story. A story that starts, believe it or not, right over your head and ends at the very dawn of time. So let's dive in.
When was the last time you really looked? Past the streetlights, beyond the clouds? Because right now, the universe is putting on one heck of a show, and you got a front row seat. Our story doesn't start billions of light years away. Nope. It begins right here in our own celestial backyard.
All right, so let's kick things off with what you can actually see, maybe even tonight, with your own two eyes. Think of this as your personal invitation to step outside and connect with the cosmos for real. That's right. The northern lights, the aurora borealis, might just be making a special appearance way farther south than they normally do. And this whole incredible display, it's all being powered by our very own star, the sun. So, what's causing all this? Well, a massive coronal hole has opened up on the sun. Just picture it like a giant cosmic fire hose, okay? It's just blasting a high-speed stream of charged particles, that's the solar wind, straight towards us. And when that stream smacks into our atmosphere, boom, it lights up the sky. That's your aurora. And here's where it gets really wild. Forecasters are saying this light show could be visible across 15 U.S. states. We're talking about places you'd expect, like Michigan and Maine, for sure. But get this, the storm could be strong enough to push the aurora all the way down to places like Iowa. That's amazing.
Okay, so if you happen to be in one of these zones, your mission is pretty simple. First, get away from those city lights. Find a nice, clear view of the northern horizon. The best time to look is usually between midnight and 2 a.m. And be patient. It's kind of like a cosmic treasure hunt, but trust me, the payoff is absolutely worth it. And hey, while you're out there looking, try to look a little deeper. You might be able to spot some open star clusters, like the Hyades or the Pleiades. They're relatively close cosmic neighbors. But then you have these giants, like the Great Hercules cluster. This thing is a dense city of stars, and the light you're seeing from it has been traveling for 25,000 years just to hit your eyes tonight. Mind-blowing, right?
Staring at those tiny, distant points of light, it's just awe-inspiring. But what if one of them was hiding a secret? A secret that could only be uncovered if we looked at it in a way our eyes just can't, revealing a history far more violent than we could have ever guessed.
And that brings us to the next chapter of our story. This is like a cosmic cold case, and it was just solved by none other than the Hubble Space Telescope. It's a tale about a star that was absolutely not what it seemed.
So the key piece of evidence here is something called a white dwarf. What is that? Well, it's the super dense, Earth-sized core that gets left behind after a star like our sun runs out of fuel and dies. It's basically a stellar ghost. And fun fact, that's exactly what's going to happen to our own sun in, about 5 billion years.
Okay, so astronomers pointed the Hubble telescope at this one particular white dwarf, called WD 0525 plus 526. And at first glance, in regular visible light, it looked, totally normal. Completely unremarkable. Just another stellar remnant doing its thing, following the usual script for how a star dies. Or so they thought.
See, a white dwarf can form in two very different ways. Path number one, a single star, like our sun, just quietly dies. It leaves behind its carbon core, but that core is hidden under layers of hydrogen and helium. Path number two is way more dramatic. It's when two stars collide in a cataclysmic merger. The violence of that collision just strips away all the outer layers, leaving that carbon core totally exposed. And this is where the whole mystery unravels. When astronomers used Hubble's ultraviolet vision, a type of light our eyes can't see, they found the smoking gun, a totally unusual, way too high amount of carbon. So WD 0525 plus 526 wasn't the quiet end of one star at all. It was an imposter. It was the aftermath of a massive cosmic smash-up, hiding its violent past right there in plain sight. And I love this quote from one of the study's co-authors, Boris Gansike. He said, "It's a discovery that underlines things may be different from what they appear to us at first glance. It's such a great reminder that the universe is just full of these hidden stories, and sometimes to find the truth, you just have to look at things in a different light."
All right, so we've gone from our own night sky to uncovering a star's secret, violent past. Now let's zoom out. Way out. We're going all the way back to the very beginning, to the first chapter of the universe, and the first chemical reactions that kick-started, everything. Because it turns out that story is also being rewritten.
Okay, so picture this.
Right after the Big Bang, the universe starts to cool down. It's cool enough for the first elements to form, basically hydrogen and helium. But then, those two combine to create the very first molecule in the entire universe. It's called the helium hydride ion, or He+. And this one little molecule, it was the crucial ingredient that was needed to ignite the first stars and light up the cosmos.
Now this is going to blow your mind. In a lab, right here on Earth, scientists just recreated the formation of that very first molecule. I mean, they managed to reproduce the exact conditions of the early universe to forge this stuff. They basically bottled the dawn of time so they could watch how chemistry itself got started. How cool is that? And what they found completely upended the old theories. According to one of the researchers, Holger Krekel, the results suggest these reactions appear to have been far more important for chemistry in the early universe than previously assumed. So, in other words, we are literally relearning the story of how the cosmos first lit up.
Okay, we've looked up at our own sky, we've dug into a star's past, and we've gone back to the universe's very first chapter. For the last part of our story, let's turn our gaze forward, to the future, our future. Because as we get ready to journey deeper into space ourselves, we're facing a whole new set of cosmic challenges.
45 minutes. Just think about that number. 45 minutes. That's the potential round-trip communication delay for a message to get from Mars to Earth and back. Now, imagine you're an astronaut on Mars, and you have a serious medical emergency. Suddenly, 45 minutes feels like an eternity, doesn't it?
This communication delay, it's a massive hurdle for deep space exploration. So to solve it, NASA and Google are teaming up to test something that sounds like it's straight out of science fiction. They're working on an AI-powered medical assistant for astronauts. Basically, an AI doctor that can be the crew's expert when mission control is just too far away to help in time.
This thing, it's called the Crew Medical Officer Digital Assistant, and its role is pretty incredible. It's being trained on specialized spaceflight medical literature so it can provide real-time analysis of the crew's health and even autonomously diagnose and treat symptoms. The whole point is to bridge that potentially life-threatening communication gap with Earth.
And that brings our whole story full circle. Think about it. We started with the auroras you might see tonight. We uncovered the hidden, violent history of a star. We even went back to the lab to recreate the dawn of cosmic chemistry. Every one of these discoveries just fuels our desire to push further, to solve huge problems like deep space healthcare, and to, become a part of that cosmic story ourselves.
I mean, in just 1 week, our cosmic story was rewritten. We found out that a normal-looking star can actually be a violent imposter, and that the birth of the first stars was way more complicated than we thought. It just makes you wonder, right? If our understanding of the universe can change this much in just a few days, what incredible truths are waiting for us to discover tomorrow?